Hi, my name is Gecory and my teammates for this power transmission design project are Javier, Hoyos, and Amador. The objective of this project is to design a power transmission system that has the following characteristic. It has to be able to transmit a maximum horsepower of 4.5. It has to have an input speed of 660 RPM, an output speed of 30 RPM, and the shaft input and output rotation must be in the opposite direction. Some of the design factors that we had was that this particular transmission design is supposed to be used for medium to low precision application. It has to be efficient, and it has to be built to handle moderate shocks. And some of the other design factors are cost effective. The power transmission system design must be built with the lowest possible design cost, and you can also consider power consumption costs and maintenance costs. And if the operation environment will be in high humidity, and the temperature will vary between plus or minus 50 Fahrenheit. Literature survey for our power transmission system, we use the right angle barefoot gearbox. Those usually have curved and oblique teeth. They're usually noise free, and they have a low maintenance cost. And they are mostly widely used in the aerospace, agriculture, conveyors, and power industry. Some of the applications that we found that this could be used for is probably a small lawnmower, or the snowblower over here that has an input of 600 RPM, and that has a maximum horsepower transmitted of 4.5.
Our consumption design basically used shared support, and it was a little complicated to do maintenance on it, because to do maintenance you have to take everything apart in order to do maintenance. So our final design basically has separate supports, so you can target any part of the system. You can take out any shaft or any gear, any bearings, and it's very simple to take apart, disassemble, and assemble again. The bill of material basically consists of a base mount, a case cover, 8 case cover screws, and 8 screws for all the mounts, 4 shafts, and 7 gears, including 2 of them are bevels and 2 are regular gears.
The structural design analysis for this transmission has to take into account the AGMA gear criteria. What this does is it takes into account design factors such as the amount of shock that it's going to be taking into account and the humidity factors, and then takes into account the bending and contact stresses of the gear. After comparing them to allowable values for the materials that we're going to be using, we can go on ahead and design safely a transmission that can last. The AGMA shaft criteria is much the same in the sense that it takes the material conditions in comparison to allowable values. For this one, it's only the stress criteria, so it's not going to be a contact or bending stress. The deflection analysis is very important to make sure that you don't have disalignment of the gears. This you do taking into account the bending forces, and it has to be done taking into account a full body diagram of the entire system. The bearing selection comes down to the radial and thrust forces that you have on the axis of the bearing. Once you select a bearing that can handle the stresses, you then have to make your mounts accordingly, and that's the end of the structural design.
An important part of this project was to do a cost analysis on the bearings and the gears and the materials we needed. For the bearings, we purchased them from Timken, and the total cost came out to be $194. And the gears were all purchased from Boston Gear, and the total cost one was $552.22. And for the shaft, we used a 1030 anneal steel with a diameter of 1.5, and the cost was about $80.
This is a design of our shaft, and it actually operates. You can play it. The idea of having that external hub on the end is actually from our senior design project. And what that can do is you can have a set of coils inside of that with a magnet ring outside of it, and you can actually attach pedals on this end and essentially power a small generator. And in conclusion, the project was very interesting. It taught us how to approach a transmission design problem from many different standpoints, including environmental aspects as well as material design perspectives.